Hey, I'm a little bit sick. Sorry for my voice and advice. So we are going to talk today about the research with codename SourMint. You could even heard about it if you're into mobile application development area. I am a member of the research team which was working on it. So let's talk about it. First, couple words about myself. I am a security research team lead at SNCC. A family guy. I have a wife and 1-year-old son. I was born in Russia, St. Petersburg, and moved to Tel Aviv about 4 years ago. I play CTF challenges as a member of 5BC team. And you can find me as Byte89 in Twitter. Also, before we start, I would like to appreciate the team which was working on the research, Raul and Danny. Thank you. So let's start. We are going to talk about mobile advertisement area, specifically about MintegralAdSDK, which is published in CocoaPods. The company created the SDK, Mintegral, is application monetization platform owned by public company Mobvista. It's based on China with a lot of different offices in different countries. MintegralAdSDK is available for both Android and iOS, but I'm not going to talk about Android version today, although all relevant links will be at the end of the presentation. The SDK allows developers to monetize on advertisement, obviously. When we started our research in August 2020, the SDK was closed source, integrated in about 3,000 applications with about 1.2 billion downloads per month overall. I think it's important to say here that I'm going to mention Mintegral company many times today in really different contexts, but I'm not blaming them on anything. All what will be presented is pure observations based on facts, and it's only up to you to decide if to blame someone or not. Now to the research. When we started it, we immediately observed some suspicious markers. First of all, the code is not open. It's not suspicious by itself, but it is really unusual for a CocoaPod to be closed source. We found that some of the classes and pieces of code are obfuscated, but most of the classes are not, so we started to look at the obfuscated ones at the beginning. Some of the strings were encoded using non-standard base64-like encoding. Eventually, we found that the SDK uses method swizzling. It's a process when you replace a native implementation of a method with your own implementation, when you replace native methods eventually. Network activity showed that the SDK uses the same base64-like encoding in the requests to obfuscate the requests. After deeper look, we found that Mintegral can collect some data which we don't expect to be collected. I'm talking about open URL tracking, all HTTP request tracking, including parameters of the requests like headers and store kit events tracking. By tracking, I mean that the SDK send log about each of those actions to their backend. The open URL method is used whenever your application wants to open a URL in a browser or as a deep link in another application. So you can imagine what will happen if you replace implementation of the method with your own. Basically, if user clicks on a link in a banner or just any external link in the app, it opens the browser. But in parallel, Mintegral SDK sends the data about the click to their backend, to their servers. This is the obfuscated data sample of such request. You can see here the URL itself, but as well many metadata. You can see the stack traces, you can see method name and class name and all the arguments, all the query parameters of the request. But what does this data is used for? Let's have a look how normally mobile advertisement works. User clicks on a banner, and Advertisement SDK send log about this click to attribution provider backend. Then user downloads application, and after installation, after first launch, attribution provider receives this data, and now you can see that attribution provider backend has both click information and install information. So eventually it can figure out which banner was clicked and who should be paid for the click. So if you have an information about all clicks made by the user, you can pretend that the user clicked on your banner as well as on a banner of different advertiser. When you can send a fake click to the attribution provider backend, and as far as attribution provider counts the second click as the one should be paid, you can earn some unfair money here. That's it about Open URL tracking. Let's have a quick look at the HTTP request tracking. Here, everything is much simpler. Every time your app makes a request to your backend, the Mintegral SDK can collect this data, including HTTP request headers, cookies, and so on. So your authorization tokens can be collected as well as some other sensitive information. One interesting fact about monetization is that usually developer integrates more than one advertisement network to the app. To do that, developers use mediation platforms like MoPub by Twitter, AppLovin, IronSource, and so on. The platforms aggregate a bunch of different advertisement SDKs and decide which banner to show and when. Hence, in many cases, developers not even aware which exact advertisement SDK are integrated in the app they wrote. And in case of the Mintegral SDK, the tracking could be enabled even if the developer never heard about Mintegral, if he installed it or he or she installed it as part of mediation platform. Interesting that SDK checks as well if you run on emulator or debugger attached to your device, or if you have jailbroken device, and or if you are under the proxy, and disables tracking in these cases. That means even if a developer has monitoring of outbound connections, no chance to catch tracking requests. I believe it's why the SDK remained uncovered for more than 1 year. On August 24th, we went public with the findings. It made a lot of noise. Even non-technical press like Forbes decided to publish it. In a couple of days after the publication, mobile marketing company Singular wrote an article about significant drop in click hijacking fraud. They didn't mention any names for obvious reasons, but it's still fun to see the effect your publications creating. Later in October, Twitter's mediation platform MoPub removed Mintegral as certified mediation network. As far as I know, at some point, Iron Source did the same. So overall, we were happy that our research helped the world to become a bit better and reduce fraud. Then Mintegral decided to make source code of the SDK public, open source. Personally, I wouldn't call it open source because you can't get the code without explicitly asking Mintegral about it. I mean, the code is not published on GitHub or anywhere else, and you can just download it. But one of our partners kindly sent us the source code, and we decided to perform Diff analysis to check if tracking functionality was indeed removed and prove that everything is okay now. Yeah, on this slide, you can see classes which were presented in original closed source version, but were deleted from the open source. The first one, CX6 stuff, is already known tracking functionality. But what is remote command? Why haven't I looked at it before? And why they decided to delete it from the open source? So all advertisement in your app is usually just HTML pages. Think about it. It's really a convenient way to represent a banner or a splash screen. If you need animation, you can use some CSS features. If you need interactivity, you can add JavaScript. And it's really cross-platform. It would work on Android, iOS, and even in the browser if you want. So we found that MTGRemoteCommand from the previous slide, from Diff analysis, is used inside what's called MTG-based bridge web view. It is the base web view used all over the SDK for almost all types of ad. You can imagine if banner is HTML page, both Mintegral and advertiser can control the banner payload, the JavaScript. This is the interface of MTGRemoteCommand, sample of how to call MTGRemoteCommand from JavaScript. It is capable to run native function by name with arguments. So it accepts JSON with 4 different keys. Unique identifier is target native class name. Name is method name to call. Parameters array of arguments for that method. And result is just helper for MTGRemoteCommand to figure out how to serialize data back to result. By the way, this is the same base64-like encoding as I mentioned at the beginning, not normal base64. So it means that both advertiser and Mintegral itself theoretically can execute code remotely on your device. And they can do it ignoring any App Store security checks, because the application is already on your device. So, and the banner is downloaded through the internet. I decided not to have a live demo for this talk, but instead I'll show you the demo video with very simple application and RC, how RC could be exploited. So at the right side, you can see terminal with evil server is running on it. The server is going to host banner with RC payload and receive data from the RC. On the left side, you can see emulator and what called secret node application. It's simplest possible simplest possible node application you can imagine. Let's have a look at it. Oh, sorry. happens sometimes. I don't know why. So now you can see like the field with text. It's the only field of the application. You can edit it and save it. And downstairs, you can see the fake Coca-Cola banner. And immediately on the right side, some data was already stolen, like it's a package name, device identifier, and default node text. Now let user change the node. While user is changing the node, you can see that exploit is running in a loop in the background. It continues to receive some data from the application. Click on update button, and now no new updated node text is on the malicious backend. So this is gem of RC. Now let's have a look at the code. The application has pretty simple UI. I'm not going to show it. And the only important thing for us right now is that the app uses two static methods to save and load node text. So basically it has node repository class, and it uses txt file somewhere in the device memory on the device. So, and the node repository class has two static methods, load to get this text file and save to put it back to the memory. This is the exploit. It is a part of fake Coca-Cola banner on your screen. The exploit is super simple as well. Basically, you just navigate to mv blah blah handle native object question mark, and then you attach serialized JSON payload for node repository for MTGRemoteCommand class. You had seen it already. The unique identifier is the node repository. It has the prefix static to let MTGRemoteCommand know that we are going to call static method of the class. Name is load, basically to load the secret node, and result is string to serialize it back. As well, you have to register a callback function to receive data from native function call. The callback is doing serialization of the result and sending it back to malicious backend. The backend is running a localhost in this case. On this slide, you can see logical diagram of the application itself and how the RC got executed. I maybe repeat myself here a bit, but I'd like to make this part crystal clear. This green rectangle is the code written by developer, first-party code. It communicates with the third-party code with the MintegralAdSDK via the MTGRemoteCommand class, which through web view with the banner communicates with malicious advertiser backend and Mintegral backend. We haven't observed any signs of malicious activity in banners we checked. And I don't know if this RC was ever used with malicious intent, but we can speculate about it a bit. Someone theoretically can target specific iOS versions, inject a rootkit, and steal any of your private data, passwords, pictures, contacts, everything. Next day, we reached out Apple, pointing that a lot of popular applications have this RC stuff. Apple reacted very fast, sending emails to all affected application owners. Interestingly, they haven't mentioned Mintegral somehow. Instead, they said you have to delete MTG invocation boxing class, or your application will be removed from the App Store. As I mentioned before, the SDK could be installed as part of Mediation platform. And it's not really obvious if MTG invocation boxing is relevant to MintegralAdSDK somehow. So this situation caused a lot of questions at the internet. You can see some of them on different forums. So the impact. Today we covered two issues came from the same SDK. First one could be used in fraud schemas and violates user rights, sending and possibly collecting PII. Second issue opens possibility for remote code execution on your device. One SDK affects thousands of applications and billions of users all over the world. Personally, I'm proud that this research eventually helped to reduce fraud cases, protect many users, and increase awareness in the mobile developers community. If you want some juicy technical details, I strongly recommend you to check our research write-up. It has all the details about both Android and iOS, really nice demo of more complex exploits. And yeah, looks like I'm not good at estimating speaking time. So we have time for the questions.
Thank you so much, Kirill. Really, really interesting research. And great to get some insight into this. We have no questions in the chat as such, but I personally have a couple of questions, so I'm going to hijack it.
Go ahead.
So who do you think should be held most accountable for apps that end up inevitably using potentially malicious SDK app or ad SDKs? Do you think that the app developers bear responsibility for not performing their own due diligence? Or do you think that the app stores themselves, like Google and Apple, need to do a better job of detecting these quicker and weeding them out?
Yeah, it's a great question. I believe this is efforts of both sides. It should be better done in both Apple and Google backends to check the application security to detect these cases, especially if library is installed in many applications and affecting so many users. So that's definitely a good point to check these libraries and verify they are not doing any malicious stuff. But as well, developer is really responsible for such stuff. So I would recommend all the developers to install some tools to scan their dependencies for vulnerabilities.
Mm-hmm. Yeah, I imagine, that's a shared responsibility model, as with all things cloud-based. So another question I have is, given all the talk recently about supply chain attacks, it's all over the news, but it hasn't really hit the mobile space yet. Do you think something like this might feature as the next supply chain attack, albeit a mobile-based version?
Yes, I believe it's definitely a good vector for a potential malicious actor to exploit mobile area. And we are actually working on really interesting research. I hope I'll present it next time in the mobile development area as well, like to show some potential vectors for attack.
Brilliant. We have no other questions. I think we'll wrap it up at that. Kirill, thank you so much for your sharing your research and knowledge with the audience. It's been great. And thank you for being part of our event today.